Alright, so we've talked about right angle trig using triangles that we already know. So let's talk about angle of elevation and depression. So we have angle of elevation first. Okay, and then we're also going to talk about angle of depression. So when we have our two different angles, so we have kind of a Z shape here. And so this is going to be angle of depression. So if you think of from this horizontal line and the angle that is created going down from that line is the angle of depression. And then the angle going up from this horizontal line is the angle of elevation. So if you were looking from this side and it was going up from this side, it would be angle of elevation. But if you were looking at the other side and we're looking at this and we're looking down from that side, it's angle of depression. Okay? So, and if you have a little person here, so we have our little person, and let's give him some crazy hair. Alright, so from his eye line, so when you look out into the horizon, you look at, oh, this is nice. This is your line of sight. So this is like if you're standing straight and just looking straight ahead without tilting your head or tilting your body or anything, that's your line of sight. From your line of sight going up this way is your angle of elevation. So if you have to move your head up to look up, this is your angle of elevation. If you're looking down from your line of sight, this is angle of depression. So you look straight ahead, and then if you look up, this is your angle of elevation. If you look down, it's your angle of depression. Okay? So then elevation means from the ground, so from the horizon line. And then you're going to go up. So elevation is from ground or the horizon line from the ground up. Okay, and depression is the opposite. So it's from the horizon line down. Okay, so that's just real quick in words what we're looking at. All right, so say we have our first example, and the example says that we have a lighthouse, and the angle of elevation, so we're going to say that we have a lighthouse. So here's our little lighthouse. And say that a boat can see the lighthouse. So we have our little boat here. Okay? So that's our little boat. All right? And say that there is an angle of elevation from the boat. Okay, that line was horrible. So from the boat, there's an angle elevation of 35 degrees. And we know that... Alright, so we have our lighthouse, and we have a little person on our ship that can see the lighthouse. The angle of elevation from that person is 35 degrees. So, and if you look, if you were in the top of the lighthouse, the angle of depression from the lighthouse is the same as the angle of elevation from the boat. And we know that our whole angle right here is 90 degrees. So to find what this angle is, we do 90 minus 35, and we'll get 55 degrees. So then we can tell that our triangle here has 55 degrees here and a 35 degrees here. And so then we'll be using these kind of concepts as we go through. Alright. So example 2. So we have an airplane. So an airplane flying at a height of 2 miles above ground. Okay. The distance along the ground from the airport to the plane is 5 miles. So distance along the ground from the airport to the plane is 5 miles. Okay. What is the angle of depression from the plane? So what is the angle, this means angle, of depression from the plane? Alright, so here's our scenario. We have our little plane, and yes, I know it looks like a UFO, but that's our little plane. And then we have our little airport here, okay, with our little runway and all this kind of stuff. So we know that our airplane is actually 2 miles up and 5 miles from the airport. So we want to know the angle of depression to the airport. So what we're wanting to know is we're wanting to know actually, so if we had our airplane, we're wanting to know this angle right here. Okay? So from what we know from our little lighthouse example, that angle is also the same as that angle. Because also these are two parallel lines that are intersected by transversal. So we know that this angle and this angle are the same. Okay? So I'm going to make a little bit more room over here. Alright? And so we have our little triangle that we need to find. Well, so from this angle we have our opposite side and our adjacent side. So we're going to use tangent of x is 2 over 5. Now if you remember, we're trying to find our angles, so we're going to be using our inverse function. So since we're using tangent, we're going to use tangent inverse of both sides so we can find out what the answer is, what the angle of depression is. So when we do the tangent inverse, that goes away and x now becomes 21.8 degrees. And so that is the angle of depression from the airplane, so this angle, or the angle of elevation from the airport. So either one, they'll both be the same. Now remember, before you start doing any of this, make sure your calculator is in degree mode, or else it will give you strange answers. Okay, so the next example, so we have example 3, and so we have the angle of elevation of the top of a tree to the top of the tree is 30 degrees from someone standing 28 feet away. Okay, so the angle of elevation, and I'm going to abbreviate there, the angle of elevation to the top of a tree is 30 degrees from a point 28 feet from the base of the tree. Alright, and you need to find the height of the tree. Okay, so we have our little tree. Okay, and so we know that the angle of elevation from this point to the top of the tree is 30 degrees. Okay, and that's a 90-degree angle. And we know this point is 28 feet from the base of the tree. We're trying to find the height of the tree, so we're trying to find x. Okay, so then we go ahead and we look. So from this angle, we need our opposite and we'll have our adjacent. So again, we're going to use tangent of 30 degrees equals x over 28. Now this is trying to find a side length, so we are dividing by 28, so we're going to multiply by 28 on both sides to get the x by itself. So then when we find this, and remember, your calculator needs to be in degree mode before you start punching this in, or else you won't get the correct answer. So the height of the tree is going to be 16.17 feet. Okay? So it's going to be about 16.17. If you round to 16.2, that'd be alright too. So we're using what we know about our angles and our trig functions to find the different parts from the word problems. Okay? So one more. Let's look at this one. So we have our next example, and you're finding the angle of elevation of the sun when a 7.6 meter pole casts an 18.2 meter shadow. Alright, so we have a flagpole. Okay, so we have our little flag there. Okay, and it's blowing in the wind. Alright, so what we need to know is from this angle here, we need to find this angle. So the angle of elevation from the ground to the sun, because the sun is over here somewhere. Okay? So it's a 7.6 meter pole, and it casts a shadow that's 18.2 meters. So then from our angle, we have our opposite and our adjacent. So we're going to use tangent of x equals 7.6 over 18.2. Now we're using the tangent function, so we're going to use tangent inverse of both sides to try and find what our angle is going to be. So when we have that and you go ahead and put that into your calculator, remember this part will cancel out. So we have x equals the tangent inverse of 7.6 divided by 18.2. And so remember, when you put that into your calculator should be in degree mode, and that should be 22.66 degrees. So the angle of elevation of the sun right here, if this flagpole will cast an 18.2 meter shadow and it's 7.6 meters tall, is 22.66 degrees. Alright, so our last one. If a plane is cruising at an altitude of 30,000 feet and wants to land, it must begin its descent with an angle of depression of 7 degrees. How many miles from the airport must the plane begin descending? Alright, so we have our little UFO plane here. And so from the plane, we know, and say this is our little airport here. I know it looks like goalpost, you'll live. Alright, so our plane is 30,000 feet in the air. Alright? And we know that from the plane, the angle of depression is going to be 7 degrees. Because from the plane's, like if the you look at the plane's eye line or line of sight, from that line of sight, it's going to be 7 degrees. So we know that this angle is going to be 90 minus 7, which is 83 degrees. Alright? And we're wanting to know how many miles from the airport must the plane begin to descend. So from the airport means horizontal distance. We're wanting to know x. Alright, so from this angle we have the opposite and the adjacent. So we're going to use tangent of 83 degrees equals x over 30,000 feet. Alright? And so when we do that, then we're going to we are dividing by 30,000, so we're going to multiply by 30,000 on both sides to try and find our side length. So that cancels out because we're doing opposite functions. So then x is going to equal whatever 30,000 times tangent of 83 is, which is going to be 24,400, excuse me, it's actually going to be 244,330.4 feet. So they need to begin their descent just over 244,000 feet from the airport to make sure that they can reach the airport with that angle of depression. Alright. And then if you were asked, just on a side note, if you were asked to find how far will the plane actually travel? So that last question, how far will the plane actually travel? So if you're asked this, that is actually asking for your hypotenuse right here. And so in order to do that, then you would have your adjacent side and your hypotenuse, and you do cosine of 83 equals 30,000 feet over y. And you'd solve for that and find that y equals 246,165.3 feet. So it actually travels 246,165.3 feet as it comes down and descends into the airport. Alright, so now you will have a short worksheet in order to go over this stuff, and the question you're going to be answering is, how does a backward poet write?